Hey there, Geology. And into week three. Last week we focused in on plate tectonics in the theory. Now we're going to look at volcanoes and some of the things that go along with volcanoes. So we'll look at what factors contribute to the type of eruptions, because not all eruptions are violent. Some of them are relatively quiet. We'll look at the various types of volcanoes and what features they have. Try to look at some of the hazards and then the relationship between the plate tectonics we did last week and the igneous activity that we see going on. So we start out with what factors determine the violence of the eruption. And I always like to look at them as being one of two things. They're either explosive or they're violent. And we look at three main factors that give us that. It's the composition of the magma. Okay, what is in the magma, the elements, the temperature that the magma exists at, and how much dissolved gases are in that magma. And that's going to determine the type of eruption that you find. One of the physical properties you talk about with these liquids, since magma is molten rock, ends up being the viscosity. Viscosity is its resistance to flow. How easy is it to flow? Where something like water flows easily, syrup that you put on your pancakes and molasses tend to go relatively slow. So that has to do with its viscosity. So things that are going to affect the viscosity of the magma itself is going to be its temperature. We look at temperature as being a major factor because the warmer a material gets, and it's not just magma, it's all types of liquids, the warmer it gets, the less viscous it is, so the easier it is to flow. The cooler it is, it starts to clump up and actually get a little harder, and then it tends to flow less easily. Temperatures then are also going to be associated with the type of magma that it is. So that's number two, the composition. How much silica is in it? Now, we talked about the composition of magma as it being one of two types of crust that we find. There is going to be those that are continental crust, and then there are those that are going to be oceanic crust. So you have high silica. Those ones that have high silicates are going to be your continental crust, the rhyolitic, the granitic type lavas. The low silica, not as many silicates in it, is going to be more fluid, and those are going to be your oceanic basaltic lavas. The third thing that we said was dissolved gases, how much stuff is in there. Most of the gas that we find inside a volcano is going to be water vapor. So it's water, and that's where we think a lot of the first oceans, and we'll get to that when we do geologic time, actually came from the outgassing of the volcanoes in the early Earth that created the oceans that we have, probably a few other factors. But those gases tend to make things more violent because as they get under pressure, they become like a pressure cooker. And if you were to just let that gas keep expanding, it's going to be more explosive. So it's that explosiveness, the volatiles that you talk about, that provide the force to blow up, as we say. So the violence of the eruption is related to how easy this gas can escape. The more it gets stuck in there, the more viscous it becomes, and the more chances it's going to have an explosive type eruption. Things that we find. One of the basic things you would think with a volcano is going to be lava, right? You see lava flowing out. The ones that you see when you see lava flow out, it's a quiet type eruption. Even if that lava is shooting, let's say, 30 feet into the air, we still consider that a quiet eruption because you're seeing the lava. There's a couple of different lava flows that it can exist as. Those that are called pohoihoi. And pohoihoi lava is more ropey and runny, as we say. It's a runny type of lava. And then there's a'a, which is going to move real slow. It's like chunks of rock that are just kind of slowly moving forward. And then we also are going to look at the gases in the next couple of slides because those are going to be more your violent eruptions that are going to come from these types of gases that are exposed in these volcanic eruptions.